Hello and welcome to another edition of Mr. Walker's Chemistry. Today we're going to be talking about balancing chemical equations. Uh, you've probably seen a lot of these in chemistry or in the real world even. Of it's the thing where you have some molecules on the left, an arrow, and some molecules on the right. So um, we need to learn not only what a chemical equation is, but why we balance it, and then finally how to balance it. So a chemical equation, what is it? Right? A chemical equation is just simply a shorthand way of writing what happens in a chemical reaction. Um, so again, you've probably seen lots and lots of these. You essentially write molecule plus other molecule, an arrow, meaning it goes to, and then some other things. Um, so let's look at one. Here's one. All right. CH4 plus oxygen goes to carbon dioxide and water. Very simple. All right. So there are some things to this that we need to know. So let me get my pen again. All right, first, everything on this side, okay, these are called reactants. Reactants. All right, reactants. I apologize for the crappy handwriting. Then we have an arrow, okay. This is called a yields sign. Yields, just like the yield sign on the road. All right, which I can't spell. It should be E-I. All right, yields. And these are called products. Okay, so reactants yield products. Simple enough. And this arrow can face either direction. It can either go from left to right or right to left. So pay attention. Okay, reactants are always away from the arrow. So the arrow is pointing left to right, it's reactants yields products. If this arrow were to be flipped, it would be reactants yields products. So just pay attention to that. Most of the time they'll be written in this way just because we read left to right. So it makes sense to do it this way. Um, and you can see it's a shorthand, right? We're not writing out the full nomenclature. We're only doing the molecules themselves, the atoms that are involved, and what is happening. Now there are a few other things here. So let me go ahead and get this stuff down. So pause if you need to. And I'm going to erase this stuff because we have other things that we need to put on here. Um, So obviously the C and all the capital letters represent an atom of an element. Okay? And then we have these little numbers here. So like this little 2 here. Call that a subscript. Subscript. And it's a subscript because script means written and then sub means below. So it is written below the rest of the stuff. So subscript. All right. A subscript is related to the number of atoms. So these are related. This subscript tells us that I have 2 oxygen atoms bound together. Here I have 4 hydrogen atoms bonded to 1 carbon atom. And we usually just don't write the 1, but there's a little 1 there. Here we have 2 oxygen atoms bound to 1 carbon atom, and so on. All right? And lastly, we have these big numbers here. We call those coefficients. Coefficients. All right. And a coefficient is, again, it's a number. It's telling us how many of something we have, but it's different than a subscript. Coefficient is related to the whole molecule. Okay. So if we were looking at this water molecule, one water molecule, okay, one water molecule contains 2 hydrogens bound to 1 oxygen. And what this coefficient tells me is that I have 2 molecules. Okay? So if I were to write this out, let's say I wanted to draw it out instead of using shorthand. This is 1 H2O, and this is a second H2O. So this whole thing is this with the 2 and everything? Okay, so 2H2O is this, for those of you who are more visual, okay? And don't be embarrassed if you need to write that out every time. In time, with practice, you'll get better at it. So for more practice, go ahead and draw out what you think this one looks like, okay? So I'm going to start drawing it, so go ahead and pause and practice. 2 O2s. What do you think 2 O2s looks like? Okay, and you should have something like this. Okay, these are O2 molecules. Remember, it's a double bond. So if you forgot and didn't do the double bond part, no worries. Go back, redo the covalent bonds. Okay, not a huge deal, but as long as you got something that looks like this. Okay, this is 2 O2s. 1 CO2. Okay, if we don't have anything in front of it, just like the subscripts, we assume it to be 1. So 1 CH4. I'm not going to be able to get that H on the side here. Sorry. Okay, 1 CH4 would look something like that, and 1 CO2 would be something like that. Okay, so something to practice with there. So let me erase all this. Oh, left some ink. Oh well. All right, so now we know what a chemical reaction is. So a chemical equation is just a way to show chemical reactions, like this one. But now we need to balance them. And what do we mean by balancing it? Well, just like in the real world with a balance, okay, you are trying to get both sides to be equal. And in a chemical equation, we have two sides. We have reactants and products. And we need to make sure that those sides are equal. They have exactly the same on both sides. Okay? So one, we have to satisfy the law of conservation of matter. That is a law of physics that we cannot break. To remind you, the law of conservation of matter simply states that matter cannot be created or destroyed. So in other words, whatever I put into the reaction has to come out of the reaction. So if 11 atoms go in, then 11 atoms have to come out. Okay? And you can only change coefficients. All right? I cannot tell you how many times I see people making the mistake of, they just get fed up with the whole balancing thing, because some of them can be quite difficult. And they go, I'm just going to change the subscripts. I'm going to make it so that I have one extra oxygen atom in this whole molecule. Well, then you start breaking the rules of bonding. Okay? You can't do it. You have to only change the coefficient. Go back a little bit. If you're not sure what a coefficient is, I just explained it, okay? So you can only use whole number coefficients, no fractions yet. All right, so some tips. How do we do it? First, write the reactants and products in the equation, making sure that all the atoms appear on both sides of the arrow, okay? So let's see what we have, okay? So let's see if it's already balanced. I mean, if it's already balanced, we don't have to do anything. Okay, so for example, let me get my little pointer out here again. Okay, so first, write the reactants products. So I'm going to do kind of a demo down here at the bottom. Let's do H2O2, which is hydrogen peroxide. It's the stuff you put on your skin when you get hurt. All right, goes to H2 and O2. Okay, number one. Let's check our tips. Write the reactants and products in the equation. Done. Reactant, product. And I want to make sure all the atoms appear on both sides. Okay, so I've got hydrogen, hydrogen, oxygen, oxygen. Fantastic. I've satisfied number one, so we'll check that one off. Okay. Number two, check to see if the equation is already balanced. Remember, when I balance something, I'm trying to make sure I have the same number of atoms on both sides. So how many atoms do I have on this side for hydrogen? Well, I have 2 hydrogens on this side, 2 hydrogens on this side. So hydrogen is balanced. Now let's check the oxygen. 2 oxygens, 2 oxygens. Oh, hey, this one is already balanced. I'm done. Okay? Now, I'm going to unbalance this on purpose. So let me get my little eraser here. Okay, I'm going to erase that too. So now I've purposely unbalanced this. Now, okay, let's check it. 2 hydrogens, 2 hydrogens. 1 oxygen, 2 oxygens. Something is not right, okay? I have more oxygens, more total atoms on this side than I have on this side. Right now I have 1, 2, 3. I have 3 atoms on this side and I have 4 atoms on that side. That is not balanced. So I need to fix it. So now I've purposefully made that one wrong. So now coefficients go in front of the substance and multiply all the subscripts. Well, let's look at this. Okay, so how can I balance this? I need to get all my hydrogens and oxygens to be correct. So H2O, my hydrogens are balanced, so I don't want to mess with those yet. Let's look at the oxygen. I have 2 oxygens, so maybe there's a way I can get 2 oxygens over here. I could try to do this. That is wrong. Do not do that. Do not do that. Okay, that is incorrect. So let me erase that. All right, never, ever, ever, ever change subscripts. Okay, I can only change coefficients, so I can only change the stuff in front of these atoms. So let's put a 2 here, because it says a 2 or a coefficient in front, okay, will multiply all the subscripts. So now I have 2 times 2 hydrogens. Now I have 4 hydrogens. Well, I still only have 2 over here. So let me go ahead and multiply those by 2. Okay, now I have 4 hydrogens, 4 hydrogens. Yay, hydrogens are done. Now let's look at the oxygen. 2 times 1, because remember there's a 1 there. Okay, so that makes 2 oxygen. And over here, if I put a 1 right here, now I have 2 oxygens. Now it is balanced. I am right. I am done. Okay, these are impossible to get wrong because you can always self-check. So let's go to the next slide. Oh yes, of course, no fractions, please. Okay. When you get to college level chemistry, then you will most definitely be able to use fractions. You know, I could say instead of doing this, I could say 1/2 water, and then just leave this as 1 and that as 1. Or that would have to be a half also. But you could do all sorts of things like that. Okay. So let's go on to the next slide. Just no fractions for now. Wait till you get to college and really have a good, strong understanding of this. Okay, so tips for balancing equations. The 1 is understood, does not have to be written, just like with subscripts. An odd coefficient will not balance an even coefficient. So what that means is if you have an odd, like a 3 on one side, you can't use a 2 on the other. It won't balance out. And always reduce, okay? So if you have coefficients of things like, you know, let's use our other reaction here. So if I had let's say I did 4 H2O go to 4 H2 plus 2 O2. Okay, I have 4, 4, and 2. Reduce to the lowest common denominator. So we would reduce to 2H2O. Goes to 2H2, oops, I forgot 2, and 1O2. Okay, so just always reduce to your lowest terms. Okay, and in a double replacement reaction, balance the polyatomic ion as a group. We haven't gotten there yet in these videos, so when we talk about double replacement reactions and balancing, we'll get more into that. But honestly, as many as these tips as I'm giving you, it's really these 3, okay? If you can do these 3, you're fine. You know, these first 3 here, that's the big ones. The rest of these are just things that can help you speed up the process if you're really good at it. Okay, balance the most complex species first and then move to single atoms such as hydrogen and oxygen. Okay, so if you have something like acetate, okay, acetate is a very large, relatively large molecule for what you guys have so far. So you couldn't start with that one because balancing that acetate will take quite a while. And double check your work, like I said. There's no excuse for getting these incorrect. It is really, really, really hard to get them incorrect as long as you just keep working on them. Okay, some will be frustrating, some will be difficult, some will be challenging, but you will get it. So let's do some examples. All right, I'll do one or two here, and then you guys are going to do some for practice. So I've got barium sulfide plus sodium chloride goes to sodium sulfide and barium chloride. Okay, so let me show you the way that I work these and the way that I found helps a lot of people. First thing, write out all your elements, because the first tip was make sure that you have the same elements on both sides. So on this side I have barium, sulfide, sodium, and chlorine. Okay, barium, sulfur, sodium, chlorine, right? Well, check, check, check. Good. All right, on this side I have sodium, sulfur, barium, and chlorine. Okay, so barium, barium, good. Sulfur, sulfur, good. Sodium, sodium, good. Chlorine, chlorine. Fantastic, okay? I have the same elements on both sides. Okay, so that's step one. Step two, how many do I have? Well, I have one, I have one, I have one, and I have one. And on this side I have two, one, one, two. Ooh, I'm not balanced. I'm not balanced. Right now I have four. Over here I have six. Something is not right. I need to make it so that everything is balanced. Well, how can I do it? Okay. Well, I noticed something. I noticed that my sodiums, there are two, and my chlorines, there are two. And on this side, I have sodium and chlorine together. So what can I do that will give me two sodiums and two chlorines, and I can only change the coefficient? I can only put a number there. Well, if I put a 2 there, okay? So let me put a 2 there. I put a 2 coefficient. So remember that multiplies. So now I have two sodiums and two chlorines. It's just like in math as if you had put parentheses around this, okay? So let's see how that changes my numbers. Well, this becomes a 2, and this becomes a 2. Ooh, now am I balanced? Well, 1, 2, 4, 6. Okay. Well, now my atoms match up. That's good. Now do I have the same number of atoms on both sides? 2 sodium, good. 2 chlorine, good. 1 barium, good. 1 sulfur. Fantastic. This is done. All I needed was a 2 in front of it. There you go. That's easy. That's it. That's all there was. Just put a 2 there and it balances it. Okay. Here's one other one. Little harder, okay? Little harder. We're starting to get polyatomic ions like ammonium, hydroxide, okay? But let's do the same exact process. Same exact process, okay? Now, here's a little tiny tip for you. If you have a polyatomic ion, you can keep those together, okay? You don't actually have to write out the entire element, but they won't tell you that in the textbook. Okay, so let's write them out like that. Let's do NH4, Cl, Ba, and OH. And on this side, we have NH4, we have a Cl, we have a barium, and an OH. All right. So we've got everything. Check, 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 check. All right. How many do we have? Well, on this side we have one of those, one of those, one of those, and two of those. Okay, in case you weren't sure, this 2 applies to what's inside the parentheses. Over here we have 1, 2, 1, and 1. Well, let's look at it. Now, if we just count the atoms, we have 3, 5. Okay, so we have 5 atoms and 5 atoms. but they're not the same. That's good. 1 and 1. Ooh, 1 and 2, not good. And 1 and 1, good. And 2 and 1, not good. Okay, so ammonia seems to be good. Barium seems to be good. Chlorine and the hydroxide are not. So let's try again. Let's see what we can do. So reevaluate, take your time, think about what can I do to make this all work out. Well, let's see. I've got 2 chlorines and only 1 chlorine. And then I've got 2 hydroxide and only 1 hydroxide. What can I do? Let's start with chlorines. So let's put a 2 there. All right, 2 chlorine, 2 chlorine. Okay, so good. Oh, but now I've changed this. So let's see, let's do 2 chlorine. Now I've changed this one. That's now a 2 also. Ooh, well, that's not balanced. Okay, so now let's try and balance the NH4. So 2 NH4, let's see. So I need 2 of those. Let's put a 2 there. Okay, so that makes this 2 NH4. And, and wait, it got everything. Oh, my numbers are all the same now. Okay, it kind of, I knew the answer here. It wasn't, this is still a pretty easy one. But you can stumble upon these. All right, I made it sound hopefully like I was stumbling upon this answer, and that's because I was just kind of working through it little by little, and eventually I got to the answer. Okay, so now that matches, that matches, that matches, and that matches. Done. Okay. Be careful. Did you see how like here I put a 2 there, and I was focused on the chlorine, but then once I was done with the chlorine, I went back and I said, oh, this also multiplies the ammonia, the NH4, so I also have to change these numbers. Okay, be careful. If you're going to get this wrong, that's probably where you're going to screw up. You're going to go, oh, 2 of these, but you forget to change that. You just go 2 chlorine. Okay, oh, great, done. All right, be careful with that. All right, so let's clear all this. All right, so you can see, all right, yes, that's the right answer. So here are some for you guys to practice with. Okay, try these. All right, P plus O2 goes to P2O5, right? Or phosphorus plus oxygen goes to diphosphorus pentoxide. Take your time, balance it out. Okay, follow those steps. How many P's on each side? How many O's on each side? See if you can change and find some coefficients that will work out for you. So I'm going to show the answer here in just a second. So please pause and practice. Pause and practice. Okay, so there's your answer. Hopefully you paused and practiced it. All right. Always double check. Can you reduce? All right. You might have gotten up to some really, really crazy high numbers. Okay. Maybe you had 8 phosphorus, 10 oxygen, and 4 of these. Reduce it. Okay. Always go to the lowest common denominator. So there's that one. Okay. Here's another one to practice. Okay. Na2O2 plus H2O goes to NaOH and O2. So take your time, see if you can work it out, balance it. The first one here, this one up here was a little harder than I think this one is. But take your time, see how it all works out. Okay, so go ahead and pause. Try it. Okay, I'm going to show the answer, so make sure you're paused. And here's the answer. All right, a little harder. Now, initially you might look at this and go 2, 2, 4. Okay, I can reduce that. No, because remember you've got a 1 out here, okay, and you can't do fractions yet. So be careful with that. All right, and one more. KClO3 goes to KClO4 plus KCl. Ooh, that one's tricky. Okay, what happened? How do you do it? Again, pause, because I'm going to show the answer. Okay, and there you go. All right, So 431 should be your answer. Make sure that you can do that. If you had trouble with any of these examples, you weren't able to work them out, I don't care if it takes you a half hour to do one, okay? It's practice right now. On the test, can you take a half hour? No. But for now, you're learning, okay? It takes time. So go slow, make sure you do it. Remember, there's no excuse for getting these wrong because there's only one right answer, and you can always, always, always double, triple, quadruple check your answer. All right. So that's it for this one. Please take your time, practice them. If you are having trouble, just create your own reactions, okay? I don't care if they're made up and if they don't actually exist in the real world. Practice balancing them. All right? So that's it for this one. I hope you learned something, and I'll see you next time.